Hello and welcome back to Math with Mrs. Becker. Today we are going to go ahead and start Chapter 2 of Algebra 2. Without further ado, let's get going. Now 2.1, we are talking about linear equations. An equation is a mathematical statement where two expressions are equivalent. What that means is that in order to have an equation, you must have an equal sign. And I always remembered that because equation sounds like equals. It's not an equation unless it has an equal sign. A solution set of an equation is the value or values of the variable that make the equation true. What that means, they are the values that you can substitute in for the variable. Sometimes you might have one solution, sometimes you might have more than one. And when you sub them in, you end up with a true statement, something like 5 equals 5 or 10 equals 10. A linear equation in one variable can be written in the form ax equals b. A and b are constants. Now remember, a constant is a number. A cannot be a 0. Because if a was a 0, it would cancel that variable out, and then it would not be linear. Linear means you have to have that single x. Remember when we talked about that in section 1.9. These are things that we will look at. All of chapter 2 looks at linear equations, linear inequalities, but we really focus on the idea of linear. These are the types of things that you will see in chapter 2. It's okay to have more than one term that has an x because we can go ahead and combine like terms. It's okay to have x's on each side, but notice we always just have a single x. We don't have any exponents. X is not underneath the radical. It doesn't have a power of 2. It's not as an exponent. These are things you will see in chapter 2. These are things that you will not see in chapter 2. Now, when you are solving a linear equation, what you have to do is perform the inverse operation. So if you want to undo subtraction, you do addition. If you want to undo division, you would have to multiply. But there is a rule. Okay, it says solving a linear equation requires isolating the variable. You have to get the letter all by itself. Using properties of equality. What this means is what you do to one side, you must always do to the other. So here, if I have 3's on both sides, okay? In order to keep it equal, if I add a 2 here, I also have to add a 2 here. If I have 3's again, if you minus 2, what you do to one side, you have to do the other. If I multiply by 2, I have to multiply the other side. If I divide by 2, I have to divide the other side. Big rule. What you do to one side, you must always do to the other. To isolate the variable, and this is where I was going, I jumped ahead a little bit. To isolate the variable, you need to perform the inverse or opposite of every operation. In order to undo addition, you do subtraction. In order to undo subtraction, you do addition. In order to undo division, you multiply. If you want to undo multiplication, you divide. So you are going to do the inverse or opposite operation. Again, what you do to one side of an equation, you must do to the other. Okay, here are some scenarios. We're just going to start off with some story problems. We have to take a scenario, write an equation. That means it has to have an equal sign, and then solve. Solve means to get the letter by itself. The local phone company charges $12.95 a month for the first 200 minutes of airtime, plus 7 cents for each additional minute. If Nina's bill for the month was $14.56, how many additional minutes did she use? Okay, the phone company charges $12.95 a month. That's called a fixed cost. You have to pay that no matter what, just to have phone service. Then your variable cost, it's 0.07 times x. The reason why the x is here is because you have to pay 7 cents for each additional minute that you go over your 200. Now this is how they calculate the bill. $12.95 for the plan plus 7 cents per minute over the 200. That's part of the plan. Nina got her bill. It was $14.56. We want to know x. How many additional minutes did Nina use? Now in order to solve for x, I need to get x by itself. The thing on the same side of the equation as x, but the furthest away, is my $12.95. This is a positive $12.95. What I want to do is have it equal 0 on this side. But again, what you do on one side, you must do to the other. So I'd have 0.07x equals, if I have 1456 minus 1295, that's 161. Now this is 0.07 times x. If I want to get x by itself, again, you have to do opposite operations. To get rid of multiplication, you need to divide. What you do to one side, you always do to the other. So x equals, if I take 1.61 divided by 0.07, x would be 23, and it represents additional minutes. So Nina actually talked for 223 minutes that month. Okay, let's do another one. Stacked cups are to be placed in a pantry. One cup is stacked 3.25 inches high. Okay, so here's the deal. We have shelving. Okay, and so like you're stacking cups. So this first one is 3.25 inches. Now, every time you stack another cup, it doesn't do the 3.25. What happens is it goes up just 0.25. Sorry, my drawing is terrible, but I want to make sure you kind of see what's going on. So they're stacking cups, but what you want to realize is that they're not going to all stack where it's 3.25 because one cup can go into the other cup. So each time it only gets 0.25 higher. How many cups could you fit between? Could you squeeze if this was 14 inches? So the first cup is 3.25. Okay, that's where you start. Plus, it's 0.25 per cup. Every cup that you add is another 0.25. We want to see how many we could fit in between those two shelves if it's 14 inches. If I want to solve this, whatever's on the same side of the equation as x but not touching, that's what we want to move first. In order to undo a positive 3.25, I need to do the opposite, which is subtract it. When I take 3.25 and I minus 3.25, this cancels. What I have remaining is 0.25x. I had 14 inches. I'm minusing that initial cup, 3.25. That leaves me with 10.75. This is 0.25 times x. What I need to do is go ahead and divide, because now x is by itself, and that's what they mean by solve. If I take 10.25 divided by 0.25, we could get 43 cups stacked on those shelves. Okay, so starting off with some kind of fun story problems. If you are solving equations with the distributive property, this is kind of cool. One little trick that I want to show you. If you have one term on the side, okay, and it only works if it's one term, but if you have a value that you are going to have to distribute, right, because I could go 4m plus 48. Yes, you can do that. But if it's one term on the outside and one term on the other side, you can go ahead and divide that out instead. That leaves you with m plus 12 equals negative divided by a positive is negative. 36 divided by 4 is 9. Now to get m by itself, to undo a plus 12, you have to add 12. Negative 9 minus 12 more is a negative 21, and you're done. One more just to make sure that it makes sense. If you were supposed to distribute a value, but the other side is only one term, it is a shortcut to go ahead and divide that. So I'd have 2 minus 3p. This side was 42, and I divide the 3, I get 14. Now to solve for p, on the same side of the equation as p, but not connected, is a 2. I need to minus the 2. I have negative 3p left. 14 minus 2 is down to 12. When you have a constant and a variable connected, this means that you're multiplying. The opposite operation of multiplying is division. Negative cancels a negative, 3 cancels 3, p is by itself. Positive divided by a negative is a negative, 12 divided by 3 is 4. Okay, let's keep on going. Here is one more like that. Again, if it's one term, go ahead and divide both sides by that negative 3. Negative cancels a negative, 3 cancels a 3, so it's 5 minus 4r. Negative divided by a negative is a positive. 9 divided by 3 is 3. Now I can solve. If I want r by itself, I have to get rid of this positive 5. To get rid of a positive 5, I have to do the opposite, which is have a negative 5, so I'm subtracting it. Positive 3 minus 5 is a negative 2. If I want r by itself, I need to get rid of the negative 4, because right now I'm multiplying the negative 4 times r. In order to cancel it, I need to do the opposite operation, which is divide. R is by itself. Negative divided by a negative is a positive. 2 divided by 4 is 1/2, or if you put 0.5, you're good to go. Okay, next idea. If you ever have variables on both sides, you simplify each side. Okay, so go one side at a time. Make sure you have no parentheses and no like terms. Simplify, that's something that we talked about in chapter 1. Okay, one side at a time. Get rid of parentheses, combine like terms. Then you want to get all of the terms, the variable terms on one side of the equation. There's an old game show, it's called The Weakest Link, and it was funny. It was this crazy, like really crabby redheaded lady, and whoever had the least score at the end of each round, she'd look at him and say, "You are the weakest link, goodbye." So I picture this, okay? I look at the numbers in front of the variable. Whoever's the weakest one, that's who you want to say goodbye to. You want to cancel that variable term and move it to the other side. Then you go ahead and isolate the variable, which means you're just going to solve like we had been doing. Okay, let's try some of these. You look at one side of an equation at a time, just one. I do not have parentheses, but I do have like terms. This has a k and this has a k. 3k and negative 14k, that's negative 11k plus 25. Now go to the other side. No parentheses, but I do have like terms. 2 and negative 12. Negative 6k, 2 minus 12, I can combine it. A positive 2 and a negative 12 is negative 10. Okay, so that's what they mean by step 1. Each side, if you look at it separately, is simplified. Now you look at the number in front of the variable. Negative 11 or negative 6. Negative 11 is smaller, so it's the quote-unquote weakest link. Get rid of it. To cancel a negative 11k, you add 11k. You are the weakest link, goodbye. I have a positive 25. Now when you add the k here, you can only add the k to the other k term because they are like terms. I can't add k's to a number. So I had negative 6k. If I add 11k, that gives me 5k minus 10. Now you solve. On the same side as the variable but not connected as a minus 10. The opposite would be to add 10. 25 plus 10 is 35. I have 5k remaining. In order to isolate my variable, I need to divide both sides by 5. 35 divided by 5 is 7. Let's do it again. One side at a time. So I'm only looking here. I'm not going to look at the side at all. Okay? There, it rolled. All right, there we go. Step 1, if you are simplifying, you always get rid of parentheses first. This is 3w plus 21 minus 5w. Remember, this does not change. The 3 only goes to whatever's in the parentheses. I can combine these two terms because they are like terms. 3w minus 5w is negative 2w plus 21. That side is simplified. Now look at the other side. No parentheses, no like terms, so w plus 12, that is simplified. You cannot have w's on both sides. This w does not have a number in front. Remember, that means that it would be 1w. Look at the numbers in front. This is where I play weakest link. Negative 2 is smaller than 1. To cancel a negative 2w, I add 2w. You are the weakest link, goodbye. I have 21 left. 1w plus 2w is 3w. I still have a plus 12. Minus the 12 because I want to get w all by itself. So anything on this side needs to move over there. If I have 21 minus 12, that's 9 equals 3w. This is 3 times w. The opposite operation would be to divide. 9 divided by 3 is 3. I hope you guys are having fun. I love solving equations. To me, this is good stuff. Okay, there are times where your solution may not exist, meaning you have no solution. Okay, you might do all of your calculations correctly, and at the end, nothing works. But you also might have a time where you end up with something called an identity. An identity means that your variables cancel, and you have something like 5 equals 5, or 8 equals 8. Well, 5 equals 5 and 8 equals 8, that always happens. And so what that means is that your solution is all real numbers. You could put any real number into that equation and it would make the two sides equal. So you can write all real numbers, or there's like a funky little symbol. It kind of looks almost like a pi symbol with an R. This means all real numbers. Okay, when you have that thing that's no solution, here's your no solution symbol. What happens are your variables cancel and you end up with what's called a contradiction. It will say things like 3 equals 5 or 10 equals 2. Well, 3 doesn't equal 5 and 10 doesn't equal 2. It doesn't work. So it is never, meaning you can never make those two sides match, so it's no solution. So let's try a couple of those. Again, step 1, you go to one side of an equation at a time. Do not worry about the whole thing. If I look here, no parentheses, I do have some like terms. 3v minus 4v is negative 1v minus 9. Now go to the other side. Now this time I have parentheses. Distribute the negative. So it's negative 5. Negative times a v, that's the same as a negative 1v. Both sides are simplified. I cannot have v's on both sides. If I look at the numbers in front, they're both a negative 1. To cancel a negative 1, I add 1. But when I cancel it on this side, it also cancels it on this side. So what I have left is negative 9 equals negative 5. Well, when does negative 5 equal negative 9? Well, that's never, because this tells us these two sides of an equation are never going to match, because negative 9 is never going to be the same thing as negative 5, so your answer is no solution. Okay, let's look at a couple more just to make sure we've got it. One side at a time. Distribute. 2 times x is 2x minus 2 times 6 is 12. I cannot combine them because one has a variable, one does not. Now on this side, I don't have parentheses, but I do have like terms. Negative 5x plus 7x makes 2x, and I still have a negative 12. I cannot have x's on both sides of an equation. The numbers in front match. To get rid of 2x, you need to minus 2x. What you do to one side, you have to do to the other. 2x minus 2x cancels. 2x minus 2x cancels. What I have remaining is negative 12 equals negative 12. Well, when does negative 12 equal negative 12? Always. So your solution is all reals. You can put any real number into this equation and the two sides are going to equal because negative 12 always equals negative 12. 2 more questions, guys, and we're going to go ahead and call it a day. Look at one side at a time. Distribute 5 times x is 5x minus 5 times 6 is 30. Go to the other side. No parentheses, but I do have like terms. 3x plus 2x makes 5x, and I have a negative 18. You cannot have x's on both sides. These numbers are the same, so even if I'm playing weakest link, the smallest number in front of x is 5x. To cancel a 5x, you minus 5x. 5x minus 5x cancels. 5x minus 5x cancels. What I have remaining is negative 30 equals negative 18. Negative 30 never equals negative 18. Therefore, these two sides of the equations never equal, so you have no solution. Last problem, guys. Let's do it one more time. Yay! Okay, one side at a time. Distribute. 3 times 2 is 6 minus 3 times 3x is 9x. I cannot combine those. They're not like terms. This has a variable. This does not. Let's go to the other side. Now here is a trick. If you ever have a minus or a negative sign, it's always tagged with what's behind it. What that means is when I distribute that 2, I have to make sure that the negative sign stays with it. So I have negative 7 out front. Negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. I can go further and combine like terms. Negative 7 and a negative 2. Negative 7 plus a negative 2 is negative 9x plus 6. This side is 6 minus 9x. I cannot have x's on each side of the equation. So what I do is I look at the numbers in front. The smallest number in front of x is a negative 9. In order to cancel a negative 9x, you need to do the opposite, which is add. What you do to one side, you do to the other. Negative 9x plus 9x, negative 9x plus 9x. I have 6 equals 6. 6 always equals 6. So your solution is all real numbers. You can put any number that is real into this equation and the two sides are going to match. And that's where we will end for today. We are just looking at the first half of 2.1. Your assignment, you are solving equations. You're looking at 1 to 17, then jump ahead 21 to 36, then do another little jump 40 to 42. You can find those questions on pages 94 and 95 in your textbook. I hope you had a great day solving equations. I'll talk to you tomorrow.